Welcome to How to Algebra, a series where I cover algebraic topics. This is the first video of the series, so I hope you enjoy it. If you haven't done so already, be sure to hit the subscribe button, like the video, comment, hit the notifications bell so you never miss an episode. Again, hope you enjoy it, and I'll see you in the next video. All right, welcome to my first recording of the new year. So this is January 2nd. It is, well, it's the 3rd now. It's after midnight, well after midnight. So let's talk about exponent properties. There are 8 rules that we're going to go over. They're very basic with some examples. So let's get right into it. All right, first, let's talk about some notation. The notation that you're going to see, there's a base, the exponent, and very basic is that anything that's raised to the power of 0 is 1. So this is a very important rule. It definitely comes in handy. All right, so the first exponent rule that we're going to look at is when we're multiplying common bases. So we say common bases is when the base of the two things that we're multiplying are the same. We're going to add the exponents. So here in the example, we have 2 to the power of 3 times 2 to the power of 4. Again, the bases are the same, so we're going to add the exponent. So 3 plus 4, 7. Too easy, right? All right, let's look at number 2, or exponent rule number 2. So I have two things being multiplied, and we're raising the product to a power. So when things are being multiplied and it's raised to a power, we can apply the power to each of the things being multiplied, basically. So in the example here, we have 3x, y, z, all to the 4th power. So we can actually apply the power to each of the things. So we're going to have 3 to the 4th power, x to the 4th power, y to the 4th power, z to the 4th power. The only thing we can simplify here is 3 to the 4th power, which 3 times 3 times 3 times 3 is 81. Yeah. All right. Exponent rule number 3. See, in this particular situation, we have a raised to a power, and that is being raised to a power. So in this case, we basically multiply the exponents. When you have a power or something raised to a power that is raised to a power, you multiply the exponents. So here in the example, we have x cubed times y to the 7th power. And all of this is being raised to the 3rd power. So we can actually apply the rule that we just said and multiply the exponents. So 3 times 3 is 9. So x to the 9th power. And 7 times 3 is 21. So y to the 21st power. All right, exponent rule number 4. Here we have a fraction, and the top term, numerator, is raised to something. The bottom term, the denominator, is raised to something. And we have to make sure that the bases match. As long as the bases match in a fraction, we can always do the top exponent minus the bottom exponent. It's always top minus bottom in every situation. So here we have a cubed to the 4th power all over a squared to the 3rd power. Here's a combination of things. So we have to apply one of the previous rules. We have a power raised to a power. So I'm going to multiply. So this is going to be 3 times 4. So 12, a to the 12th power, and a squared cubed. So we have 2 times 3, which is 6, basically. All right, so a to the 12th power over a to the 6th power. It's always top minus bottom. So we're going to have a to the 12 minus 6, right? Because it's top minus bottom. Always top minus bottom. So 12 minus 6 is just 6. So we have an important note here that whenever we do our calculations, that the final exponent must be positive. So here we have a to the 6th power. And this is positive, so we're good. Let's look at another example where it's not the case. All right, so exponent rule number 4 basically continued. In this example, so if we apply the power of 4 to each of these exponents, right? So we're going to just basically multiply because we have exponents raised to an exponent. So 4 times 3 is 12. 4 times 2 is 8. And in the bottom, we can apply the same idea. So a cubed and b to the 15th power. All right. If we do the top minus the bottom for the common bases, we're going to get a 12 minus 3 and b 8 minus 15. So 12 minus 3 is 9, and 8 minus 15 is going to be negative 7. So taking into account the note that we just had where we don't like negative exponents, this negative 7 will in fact move into the denominator. So any negative exponent basically moves into the denominator. That's a rule that's coming up here in a moment, so just keep that in mind. All right, exponent rule number 5. Here, when we have a fraction that's raised to a power, we have a over b all raised to n, right? Some number. We can apply the power to basically the top and the bottom number. So in the example, we have x squared z to the 5th power all over 2y cubed. And all of this is being squared. So I'm going to apply the square to the numerator and the denominator, top and bottom, basically. All right. And then here we can apply the rule again by multiplying the exponents. So on top, we have x to the 4th, z to the 10th. In the bottom, 2 squared is going to be 4, and 3 times 2 is 6. So y to the 6. All right, exponent rule number 6. We do not like negative exponents. We just mentioned this in a few examples ago. So here, if we have a to a negative exponent, we can basically make the exponent positive and move it to the denominator, or move it to the denominator and make it positive, however you want to look at it. So in the examples, we have x to the negative 2, y to the 5th, z to the negative 3 power. So all the negative exponents will become positive and they'll move into the denominator. And it's all being multiplied to. So y to the 5th over x squared and z cubed. There's nothing else we can combine, so we just leave it at that. So the idea is that we don't like negative exponents. That's pretty much the gist of it. All right, number 7. It's almost the converse of what we just said, right? So if we have a negative exponent, but this time in the denominator, then we can move it to the numerator and make it positive. So here we have 1 over a to the negative b power. Well, we can move this to the numerator, right? Because it's implied that it's over 1. So this is in the numerator for sure. And the exponent is positive. So here in the example, we have x to the negative 2, y to the 5th, all over x to the 4th, y to the negative 2, and z. Okay, applying what we learned previously, we can do the common bases, top minus bottom. So x to the negative 2 minus 4, y to the 5 minus negative 2. All right. Negative 2 minus 4 is going to be 6. 5 minus negative 2, that's essentially plus. So 5 plus 2. And we get x to the negative 6, y to the 7. All over z, right? Z stays behind. There's no negative exponents, and there's nothing common that it can combine with. So z just stays behind. However, x to the negative 6. So we don't like negative exponents, right? So we're going to move this to the denominator and make it positive. That's what we did. All right. The last rule, I feel like this went very quickly, but, sometimes it'd be that way. So the last rule is when we have a fraction that's raised to a negative exponent. The idea here is that we flip the fraction and make the exponent positive, and then apply whatever rules are appropriate. So in the example, we have x to the 4th, y cubed, all over z to the 8th. And this is being raised to the negative 3 power. So the first thing I'm going to do is make it positive, and flipping, using the reciprocal basically of the fraction. So z to the 8th comes up, and then the x and y come down. And then the exponent's now positive. And now we can apply the previous rule, and we have a fraction that's raised to a power. We can apply the power to the top and bottom. So 3 times 8 is going to be 24. And then 3 times 4 is 12. 3 times 3 is 9. And we've arrived at the final answer. These are very basic, but try to master each of them, because the pinnacle of the problem is not just one rule at a time, right? The most we saw here were probably 2 rules at a time, but these can get very complex where you have multiple rules that need to be applied, and you always want to apply them in the correct order. But hopefully this helped out, and got it under 15 minutes. So let me know what you think.